Takže ochutnajte, dajte si, pretože asi aj o tom bude čiastočne možno nejaký zázračný recept na vynikajúce guacamole. Nám odprezentuje človek, ktorý sa pripojí cez tzv. Zoom. Volá sa Eyal Itkin a je to Technology Leader at Checkpoint Research z Checkpoint. Je to špeciálne prekvapenie z Izraela. Prednáška samozrejme bude v anglickom jazyku, takže sme pripojení? Sme pripojení, takže ladies and gentlemen, Eyal Itkin, HackFest 2020.
Hello, everyone. Thank you for attending my talk today called Would You Like Some RCE with Your Guacamole? Before we begin, just a brief introduction. My name is Eyal Itkin. I'm a security researcher working on Checkpoint's research group. In our vulnerability research team, we usually focus on searching for new vulnerabilities in embedded devices, in network protocols, and in pretty much everything that might be susceptible to attack. And after we find the vulnerabilities, we report them responsibly to the vendors and help them patch the product so that users worldwide will be able to use a more secure product in their day-to-day activities. The background for this specific research started a few months ago, on the 15th of March this year, when the COVID-19 shelter-in-place officially began in my country, in Israel. Since we started working from home, a day afterwards, we had a daily meeting, which was now a daily virtual meeting using Zoom. And we started talking about a new technical solution deployed at our work so we could work from home. And this meant that I could work from my apartment and remotely connect to my physical computer on campus. So I have all of the capabilities to work on my work computer on campus and still work safely from my home. And my boss asked me to look on this solution because it is based on remote desktop protocol, or RDP. And I'm already quite familiar with the protocol because of past research projects on it. So my boss asked me to look on it, and he specifically said, I hope you won't find anything. I really like this product. I really want to use it. So this is how we began this research project. And one day afterwards, the research itself began. Just some introduction about RDP. RDP stands for the Remote Desktop Protocol. It's a protocol proprietary from Microsoft designed in order to enable us to connect to a remote Windows machine. The terminology of the protocol is that we are going to use a client that is going to connect to a remote Windows machine, which is referred to as server. Although it might be confusing, this remote machine doesn't need to be an actual physical server. It could be my remote computer on campus. It could be an actual physical server somewhere in the data center. And it could also be a remote Windows virtual machine. So it could be a local virtual machine or a remote virtual machine. Essentially, any virtual machine that operates using the Windows operating system will allow us to connect to it using this protocol. The protocol is also known as MSTSC, after Microsoft's built-in RDP client called mstsc.exe. And on top of Microsoft's client, there are also some popular open source clients, such as FreeRDP and our desktop. So you could use your Mac or your Linux machine and still remotely connect to a remote Windows machine. Before we begin the talk about Guacamole itself, we also had some prior work on what we called Reverse RDP. So we presented the Reverse RDP attack last year, and we found multiple critical vulnerabilities in various RDP clients. You can read more about it in this link to our research blog post. And we even presented our research last year as part of Black Hat USA. So you can find all of the details on Black Hat's website and the video itself for our talk alongside the researcher from Microsoft. The important part about Reverse RDP publication was that one of the clients we studied last year was FreeRDP, which is the most mature open source client. And the question arises, since all of the vulnerabilities were already patched because we disclosed them to the vendor, to the open source maintainers, and we helped them fix it, why is it interesting now? All of the vulnerabilities are patched. I don't know of any new vulnerability or remaining vulnerability in any of the RDP clients, but since we already looked on these clients last year, we are quite familiar with the code. So it's going to be really helpful if we will encounter these RDP clients somewhere in the Apache Guacamole setup. So what is reverse RDP? In the reverse RDP attack scenario, we start with a single infected corporate computer. It could have been infected using a phishing email, a bad USB attack, pretty much every attack you could think of. We already start with one compromised computer, and we intend to escalate our privileges in the network. So we want to collect domain admin credentials. We want to control more computers, more servers, but we don't want to work hard for it. We want somehow to ambush privileged users and steal their credentials or take over their computer without doing a lot of work. So if the usual malware will try to hide itself, we're going to do the exact opposite. We are going to slow down the computer. We're going to pop up error messages, cause the computer to make some noise, maybe even crash it once or twice. We want the user that is actually using this computer to suffer, to be miserable, and to know that something is wrong with his computer. After a few such days of work, the user will open an IT ticket saying something is wrong with my computer. Could you please check it out? Hopefully, after a week or two, someone from IT will actually connect to the computer, and hopefully they will connect using remote desktop protocol. When this connection starts, our attack will start, and we hope to exploit vulnerabilities in the RDP protocol or in the RDP client. So we will be able to take over and control the computer of the IT staff. This attack could be used in order to collect credentials from the victim, being domain admin user or any privileged IT user. But the most lucrative attack will be to attack and take over the entire computer. Thus, we have one more infected computer in the network, and most probably it is an important computer because it's an IT staff station. So this is the reverse RDP in a nutshell. We're going to attack computers that are trying to connect to us. Time to look over Apache Guacamole. And the Apache Guacamole software is an open source architecture, software and servers, in which basically we could use our web browser in order to remotely connect to our corporate computer somewhere in our network. So I can use my mobile laptop or even my mobile phone, and using the browser, I will connect to a Guacamole gateway, sorry. I will authenticate myself through the web server. And once authenticated correctly, the proxy will initiate the matching connection to my computer on campus. So it could be an RDP connection, a VNC connection, or even an SSH. There are multiple supported protocols. And whenever I connect successfully to the gateway, the proxy starts a new connection to my physical computer, say RDP connection. And then I will send messages in the Guacamole protocol to the proxy. The proxy will translate these messages to the matching RDP events that will be forwarded onto my computer. And when my computer on campus will respond using the matching RDP event, the proxy will translate it back to the Guacamole protocol and send it back to us. So we are going to focus on this specific server in the architecture because it is responsible to most of the work. It bounces messages from the Guacamole protocol to the RDP protocol. And this is the computer that actually connects to my physical computer on site. So let's dig in. The web server is referred to as Guacamole client, and it's an open source. You can find it on Apache's GitHub. And the proxy server is also referred as Guacamole server, which is the component we're going to focus on. As I said before, the proxy does most of the work. It picks the right protocol, which is RDP in our case. It creates a new session for connecting user for ourselves and actually starts an RDP connection with the physical computer and pretty much does all of the work. And the most important part from our perspective, the proxy is going to use free RDP in order to connect to the physical computer on site. So we are already familiar with this specific RDP protocol. We already know pretty much how it works. And now we need to check how Apache is going to use this external open source software. Usually during the integration, we suspect to find a few bugs along the way. And the question arises, do we even need a zero day? Do we need a new vulnerability? Well, the first published vulnerability of Apache Guacamole is version 1.0. It was released in January last year, and it only supports a vulnerable free RDP version. So not only it relies on a vulnerable free RDP version, we are the researchers who actually found this vulnerability in free RDP. And last year, we already demonstrated we can take over a client that uses this vulnerable version to connect to our malicious machine. So if clients will only use Apache Guacamole version 1.0, we already know how to take over their computer. And in this case, to take over the Guacamole gateway. We already have a demonstration for that. So essentially, we won't need any new vulnerability in order to attack the gateway. Sadly for us, there is a new version of Apache Guacamole, version 1.1, which is the latest at that time. And it was released at the end of January this year. And of course, it uses the patched free RDP version. At this point of the research, we thought to ourselves, well, come on, what are the odds of people actually use the most updated version? It's only 1.5 months old. Most probably, most of the organizations still use an older Apache Guacamole version. They are still vulnerable to the attack. We can take over the Guacamole gateway and that's it. But it turns out that organization actually use the latest version. Actually, we use the latest version in Checkpoint. So I had to search for new vulnerabilities in the latest version. And hopefully this new vulnerability will enable us to attack all of the versions using this single vulnerability, if we will find one. So it's time to talk about the basic findings. Well, the good news for us as vulnerability researchers is that we found a few vulnerabilities. The first vulnerability being a 64 kilobyte information disclosure vulnerability from the heap back to the server, which is essentially a Heartbleed style vulnerability. If a user will try to connect to an infected machine, the infected machine will be able to send a malicious message to the Guacamole gateway, and the Guacamole gateway will respond back to the malicious machine with 64 kilobytes of memory from the proxy itself. So there is an attack to leak information from the proxy and back to the malicious machine inside the network. There is a similar vulnerability in the code in which the malicious machine inside the network can cause the proxy to leak back information to the browser of the connecting user. And if that wasn't enough, there is a third vulnerability, same style of vulnerability. We can once again leak information back to the malicious computer inside the network, this time in a feature that is disabled by default. So in most probable scenarios, this feature won't be accessible to attackers in a standard deployment. And in addition, we also found a few more vulnerabilities in FreeRDP itself. So essentially, everywhere we look, we find info-leak vulnerabilities. So we have info-leaks everywhere, but info-leaks are not enough. We want to take over the Guacamole proxy, and leaking information from it won't really help us. We'll need more vulnerabilities. So the bad news are that we scanned all of Apache Guacamole, but we only found info-leaks. Then we scanned again FreeRDP after we already did that last year, so it was quite tiresome, but we did it again. And again, we only found new info-leak vulnerabilities. We don't have any memory corruption vulnerability. we still can't take over the proxy. So at this point, the proxy looks quite solid from a security perspective. And it's time to go deeper. You can never know during a research if you stopped before a critical vulnerability or there is no critical vulnerability whatsoever. So you should never stop trying until you find the actual vulnerability that you were initially looking for. So never stop trying. And after we dug in a bit deeper, we indeed found a new memory corruption vulnerability, and in this case, an dangling pointer. Some details on the background. RDP separates the different data types into channels. This means we have a channel for the clipboard redirection. The clipboard is a shared resource by default between the client and the server, and the clipboard channel is called clip RDR. We have an additional channel called RDP sound, which is the output sound from the server, from the Windows machine we connect to. And we have additional channels for redirection of the printer, redirection of file system if enabled, and in Guacamole we even have a redirection for the input from the client back to the Windows machine, but it's off by default. So we have multiple channels, each for their own type of device that is redirected between the server and the client. And since in the clipboard, for example, we can copy a file and paste it on our machine, this file could be quite big. So we need some way in order to split this huge file into smaller fragments and send these fragments over the channel so they will reach correctly our machine. And in this case, RDP uses in-order fragmentation to support such large messages. And this works in a way that we have a flag called flag first, which signals the first fragment. And we have an additional flag called flag last, which signals the last fragment. And essentially, we break our message into fragments, and we send them in the native order we split them up. And when the last fragment arrives with the flag of flag last, the receiving side knows it received all of the message, it reassembles all of the parts, and send them onward to be handled, in this case, in the clip RDR channel. So how does it look like in Apache Guacamole? Well, as we can see, we are checking for flag first, and we're even checking that our total length isn't too high, in case we'll chop it down. And when we receive the first flag, we will allocate a new stream, a new buffer, that will have enough place to store all of our incoming message, fragment by fragment, according to the total length. After we allocated the buffer, we ensure that we have enough capacity for the current fragment inside the stream, and we append it to the end of the stream. After we receive all of the parts, we check if they received the last fragment, flag last, and if we did, we seal the length, and we send the entire buffer, the entire stream, to be handled by the appropriate receive handler. And this is where it becomes interesting, because after we finished handling with the message, we free the stream. We no longer need it, but that's it. We only free the stream. The pointer still points to a freed memory buffer. No one sets the pointer back to null. So no one knows that we finished with the stream because there's no way to differentiate between an active stream with a valid allocated buffer and a freed stream that we finished working with that points to an invalid memory address. So we have a dangling pointer that points to a freed buffer. And when we receive new fragments, we only allocate the buffer when we get flag first. If the flag first will somehow disappear and we right away receive the second fragment, no one will allocate a new buffer, and we simply continue on writing the new fragment into the freed buffer in memory because there's no way to check if our stream is active or not. So combining these two parts together, we have a dangling pointer, and we hope to write into the freed memory. So let's look how it works. The proper way to use the stream by Guacamole is that the stream has multiple fields. We have buffer, which is a pointer to the buffer's start. And we have pointer, which is a pointer to the current position inside the buffer, and it will be incremented fragment by fragment when we append the fragments inside the buffer. As we saw earlier, the stream is allocated on the heap when we get the first flag, and each fragment will be written to the stream, advancing the pointer accordingly. When we receive last flag, we will free the stream and destruct back to the heap. But as we saw in the code, the global variable will continue to point to a freed buffer. So what does it mean? When the program starts, we have input stream, which points basically to something. No one initialized this variable, so we don't really know what it points at. When we send the first message with all of the fragments as we should, the program will allocate a stream, which will point to our user buffer. And then when we send all of the fragments, the buffer will be handled and then freed. However, input stream is still pointing to the stream in memory, although the stream was free. So input stream essentially points to an invalid memory region, but it looks like a valid memory region because we don't have any way to differentiate between them. At this step, the attacker will send a new message that will be allocated using the same memory place, and the message will look like a fake stream. So the attacker fake stream will look like the following, with a corrupted pointer, which points to whatever arbitrary memory address the attacker wishes to use. And input stream really thinks that it points to a valid stream that points to dead beef. It doesn't know that this stream was corrupted. And the last step in the attacker will send directly the second fragment without the first fragment, so that this fragment will be written to the crafted stream we arranged in the memory. And effectively, we will write to memory using the dangling pointer. So we get an exploit primitive enabling us to write whatever data we want to an arbitrary memory address at our liking. And this is a very strong exploit primitive. If we wrap it all together, during this research, we found 4 critical vulnerabilities in the integration of Apache Guacamole with FreeRDP, which makes sense because in the software world, integration is hard. We also found 2 lesser vulnerabilities in FreeRDP, which turned out to be duplicates because when we send them to the open source maintainers, we received a notification that a few hours before we sent our mail, another security researcher already notified them about these vulnerabilities. So we were late in a few hours, but that's life. We found 3 massive hardware-style info leaks in Apache Guacamole. And we found 1 use after free vulnerability, the dangling pointer, which is a potential for a remote code execution, which we will demonstrate in a few slides. And we tried to exploit the Guacamole proxy using the remote code execution vulnerability we found. And we successfully took over the proxy when it connected to a malicious computer we simulated inside the network. And we managed to execute code over the proxy and pop a crack. So it looks like we're done. But it turns out that we only took over a single process. The Guacamole gateway creates a new guacd process per connection. So if a specific user connected to his infected computer inside the network, we were able to execute code over the guacd process of that specific user. But we don't have any control over the same Guacamole session of, say, the CEO or the boss of this employee. So we only have a single session. Each session has its own process, and the process is run with lower permissions. So we can't really control the entire gateway, which isn't so good for us. And traditionally, we will need some additional vulnerability in order to escalate privileges and take over all of the sessions of the gateway and controlling all of the gateway. But we did manage to find a few design vulnerabilities in the gateway itself, which still allowed us to take over all of the sessions, as we can see here in this demo. as we can see in the right, we have our malicious computer already infected inside the network, which is waiting to ambush the client that will connect to it. When our vulnerable user unknowingly will connect to his computer, he will start the attack. And the infected computer inside the network will exploit the vulnerabilities and take over a single guacd process in the gateway. Then we will use the design vulnerabilities to hijack the session of the CEO. And as you can see, we can fully control the Guacamole session of the CEO. We can control the keyboard. We can see the session. We can pretty much do anything we want with all of the connected sessions in the organizations, even with the session of the CEO, which works remotely from home due to COVID. So, the patching status. Well, of course, the checkpoint, we integrated our patch right away. We worked on the patch, we sent it to our IT with a detailed explanation, and they integrated the patch right away in our production servers. We also coordinated the disclosure with Apache. So we started the research on March. At the end of March, we sent a report to Apache, which responded right away. However, patching vulnerabilities, especially in a time with a lot of works and to-dos to cover due to the high amount of clients that use Guacamole in the shelter-in-place. It took Apache a lot of time to handle the bugs alongside new bugs until they issued a new release, version 1.2, which essentially took them 3 months. So at this time period of 3 months, we were protected from this attack in our network, but all of the customers of Apache Guacamole were still vulnerable because the time it takes to patch vulnerabilities, issue a new version, and then notify customers about it might take a lot of time in some scenarios. So in this case, the patching actually took practically 90 days, which is a pretty long time period. And this is a good reminder to tell you that if you are using Apache Guacamole inside your network, well, make sure that your networks are patched. This is a serious vulnerability. It will allow an attacker to take over all of the gateway, effectively controlling all of the sessions of all of your users that work remotely. In our country, we still work remotely, so it's pretty serious. And you can read more about it in our detailed blog post in this link. So that's practically it. Thank you for joining the session and questions.
Hi. We have a few users, so a few customers using Guacamole, but we always tell them to put it behind the VPN. I saw on your diagram that you simply expose it directly to the internet. Is this the good practice?
In our case, I can tell from how we work with it. We have a multi-factor authentication from our corporate domain. So I have to authenticate myself to the corporate server using multi-factor authentication, and only then the server will point me to the login screen of Apache. So it pretty much blocks most of the attack surface from clients that try to connect to their remote machine. However, in this attack scenario, we assume that we already took over a single computer inside the network using, say, a phishing email. And unknowingly, when some user will try to legitimately connect to that infected machine, the infected machine will attack back the Guacamole proxy and take over all of the proxy and all of the sessions of all of the users that are currently connected. So hiding the login behind several security measures is a good security practice, but it won't protect you from this attack scenario in which we actually attack back from inside the network, the proxy. So you won't have enough layers for that. We actually, when we drew the architecture, let me show that again. When, a minute. Okay, it will take some time, but when we drew the architecture, we actually added some protections that we thought will make sense in the network architecture that weren't there in the recommendations by Apache. As you can see now, in this network diagram, we added a firewall between the client network and the web server, but we also added a firewall between the corporate network and the proxy. And that is mainly because the proxy has an open TCP port, which is used to communicate between the web server and the proxy using the Guacamole protocol. And you don't really want computers inside the network to simply connect to that port in the proxy and start sending commands to it. So the Guacamole gateway needs to be protected both from the internet and from the actual corporate network. And you will need some sort of product that will be able to detect our attack and block it, so to protect the proxy. And of course, the best way is just to update the Guacamole gateway to the latest patched version.
Pokojne, priatelia, ak sú teda ešte nejaké otázky, tak dajte vedieť. If there are any other questions, go ahead. Pozerám sa ešte dozadu. Zatiaľ žiadna ruka hore. No hand up. Takže sa asi poďakujeme v tejto chvíli. Tým pádom, thank you very much. I think it was a great presentation. I didn't understand a single thing you were talking about, but that's fine. That's fine. I'm not from the business, so that's completely okay. I just have a simple question at the end. Do you prefer guacamole with a bit of salt and chili or without chili?
Without chili.
Okay, without chili. Thank you very much. Veľký potlesk, priatelia. Toto bol Eyal Itkin. Thank you very much. Technology leader at Checkpoint Research. Checkpoint. Pozdravujeme Izrael. Ďakujeme veľmi pekne. Goodbye. Thank you very much. Take care.